the Convair NB-36.
The program began in September 1955 when Convair's nuclear test aircraft first carried the aircraft shield test reactor aloft. The nuclear test aircraft was a conventionally powered B-36 modified to carry a shielded crew compartment for the 5-man crew, a half-scale crew compartment, and the aircraft shield test reactor and its nuclear instrumentation. The crew compartment utilized lead and rubber as shielding materials. The cylindrical half-scale crew compartment was carried to simplify dose rate analysis. Sleeves of different wall thickness were slipped into the half-scale crew compartment to obtain dose rates as a function of wall thickness. The radiation source, the ASTR, was a water-cooled, water-moderated reactor designed to operate horizontally. Shield tanks, which surrounded the reactor core, could be filled or drained in flight to change the source pattern. An external lead shield augmented the gamma shielding. The ASTR was rated at 1 megawatt maximum thermal power. Thus assembled, the NTA was used to study the effects of air, structure, and ground scattering of gamma and neutron radiation. The flight program was intended to determine the air and structure effects. At first it was thought that by a simple process of subtraction, the 3 individual components of scattering could be separated into air, structure, and ground effects. But it was soon learned that the structure was changing the air and ground scattering to such an extent that it was impossible to separate the 3 effects directly. Additional information on air effects alone was necessary. Convair then planned to take the ASTR and the crew compartments to the tower shielding facility at Oak Ridge, Tennessee. This program has contributed greatly toward developing efficient shield systems and constitutes a major step forward in development of nuclear-powered aircraft.